Hi everyone, welcome back to my workbench. I'm dropping down to 720 on my video resolution because the uploads have just been so darn huge, it's not very efficient. So today we're working on the Tiger Learning Computer, which is actually an Apple II internally, Apple IIc I believe. Hard to believe this was made in the 90s and they're still using Apple II technology, which was from the 1970s. Okay, so what is today? April 24th. Okay, so this is the actual you see up in the corner here. That's actually the capturing the video output from the learning computer. I never could get a mouse to work with it. I think I had a very specific mouse because I have a PS2 mouse, but doesn't work with this guy. I don't know why. So if you go through the cartridges it use are very similar. Don't really act like disk drives. They act like cartridges, and that's because they're using this ROM chip as their source. There's one rewritable drive on here, and there's a couple that came with stored in the top here. There's a storage bay. Let me move this out of the way a second. Ooh, wrong one. Wrong one. You can see there's a storage bay in the top there where the screen would be. This doesn't actually have a screen, but I found for taking videos I kind of put the screen where it should be if it was a laptop. It's got the world's worst keyboard, that's for sure. And since I don't have a mouse, I have to navigate everything by see, this is a simple interface here. So in slot 1 there's a no name which has the rewritable, and the other one that's got the Apple Works in it. And you can even look, you can see all these files are in there. Escape from there, and then I go on the no name drive. There's not much I can do there. Disk, Apple. If I go run, it'll actually pull up. Wow, it's dark. Okay. Well, trust me, it's there. Okay, we'll go. Let's see. And whatever. Must be. Whatever. Alright, let's reset this thing. So what I'm going to do today is figure out how to actually swap the pins out. This is the cartridge. This is an Apple Works cartridge. It had already been opened previously to take a look at it. So I didn't put, there's a little slider mechanism here I took out already. So now the little back cover comes off. So I'm just trying to keep everything straight. So this, it's like this, and you open her up. So this is the orientation it's in as you plug it into the system right here. This chip here, this UM23C, is a what they call it. They call it mask programmable, but it means that you can switch between this, and that is set by. You can even see on the artwork they put on the board was. I should get close on me. Let me get this window all the way here. You see, even on the board, it tells you. Change the focus a little bit. Okay, it says it is 4 meg standard when J3 is used. It's 2 meg standard when J4 is used. It is 2 in 1 when J3 and 4 are not used. I don't know what 2 in 1 means. Okay. And this is where I got the numbers from originally, because it actually has the UM number on it. I believe it's a Taiwanese company, so it was released on December 6, 1996. So they're still using Apple II technology in 1996. And in this case, the J3 is used. That's this little blob. It's a 0 ohm resistor they put right there, and that is your that's the one that sets it to it's the 4 meg mode, so 4 megabits of storage. Or for yeah, it's got to be the 524 288 by 8 bit organization. So yeah, that bumps it up. So this guy, ironically enough, I don't really need it right now. So the challenge is, once I get my focus fixed, put this safely somewhere. Hold on a second. I'm gonna definitely turn that volume down. Okay. Oh, there we go. Don't want to make everyone too deaf. Okay. So let's fix our focus here. So on this guy here, I know it goes into the system this direction, and the key is to figure out the problem is the chip they use is underneath. This is known as glop top, so it's completely covered. Let's get this lower so we can see what we're doing here. Alright, so the problem is this glop top here covers up the chip itself, even though it's a 40 pin chip, or actually a 40 pin chip. There's only 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34. There's only 36 pins come out, which I knew that because there's a few on here which don't need to come out. So with the programmer, the only ones I really need to worry about are these are address lines here, A17 through A0, and then you have your output, or is your let's see, those are address lines. Then you have more address lines over here, and then you have your outputs, which are here, here, all the way to here. Then your VCC, which is the controlling voltage, and then you're going to have your grounds. Well, it has 2 grounds in there. They probably only connected 1. Well, I'll take a look on the chip. So what's going to give me a clue is where this VCC line comes in and where the grounds come in, because this is a curious chip. Usually you'll have a VCC up here or down here. So the VCC is down here and the grounds are kind of in the center. So here's this guy here, I believe, is the one that sets the byte size. So we're gonna have to look at actually look at the traces of this sucker. All right, so looking at it, my guess would be bunch comes out, but you can see this guy here, that's a nice thick trace, and that's going out to here. So that's most likely the VCC line, pin number 21 right here. So what I'll do is kind of make that assumption, because this is the VCC, and the next line over. This is the confusing bit, because I'm sure they fanned it out. So this guy here is 21, which is just a trace going directly to this. We'll call this guy 1, just so I know. I assume this is probably, there's a U here, so they probably put the chip in this orientation. Just gonna put a little marker dot on there so I know which one's which. This is most likely this is the keying feature right there, so it's most likely that. So now this is my favorite notebooks because it actually has dates built in the top. You circle it. Alright, so this will go, this column we'll call it the, this is the chip, and this will be the edge connector. So I'm working through reverse engineering this. Alright, so we see pin numbers, let's go. This is exciting viewing, isn't it? Alright, so pin number 21 here is, we'll go, let's call this 1 through, how many did I say? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it's 36, it's 18. We'll go 1 through 18 on the top. This is on the top edge, and we'll on the bottom edge. This is chip side. It's gonna call it. It doesn't matter what I call it actually, but let's see. Let's go. Let's start 19 down here. Alright, so this is, so now we know this is pin 21, which is VCC, and this is going to go to pin 18, VCC. So we'll call that 21. Alright, this is where the challenge comes, because this board has some conformal coding, so I need to figure out which one's which. I need to manually trace through all of these. Oh lordy. What I'll probably do is, alright, there's a couple resistors here. I sure hope that's, I don't know what this is here. I've been trying to life of me figure out what it is. There's the one here. It doesn't really go anywhere. Even holding it up to the light, it doesn't really go anywhere after that spot. It is so odd. I don't know what it is. Anyways, the problem I'm running into is this is all coded, so I really can't ohm it out. So I'm going to have to go through one by one and trace it back. Alright, I'm not going to make you sit through the whole video of me tracing this out, but you can see what I'm going through to figure out what's going where. So I figured out one pin, and see the grounds, I'm going to kind of go midway through here somewhere. Guessing it's either going to be this thick one here. Let's take a look. This goes here. that guy. This is towards my finger. Is there a ground plane? Kinda. Oh, this is so confusing. That goes there. Yeah, this guy here definitely looks like ground. So I guessed right. This is the ground pin right here. You can see on the same side. See, this says ground. This is a thicker one here. This is the ground, and you can see right by it is the chip enable. So that guy goes here. So yes, I still have a traditional phone. Okay, the wife needs me for something. I'm gonna head up and I'll start tackling this later. So thanks for watching.